Hi folks, welcome back to AP Calculus with Mr. Robeson. Today we are looking at integration by partial fraction decomposition. I know it sounds a lot scarier than it actually is. It just involves some factoring. So like we could solve this integral by completing the square, but it's not going to be fun by completing the square, and it's not going to be pretty by completing the square because we'd have to divide this -5 by 2, and we get -2.5, and we'd be squaring that, which is what, 6.25? So we'd have x squared minus 5x plus 6.25 plus 6 minus 6.25. So this would be x minus 2.5 squared plus, and this would be 0.25, which is the same thing as a half squared. So now we have perfect squares on the bottom, and we can and we're adding these perfect squares, so we'd use u as x minus 2.5 and a is 0.5. And we'd go into arctan. So we'd have 1 over a, so 1 over 0.5. The arctangent of, let's see, x minus 2.5 over 0.5 plus c. Not really a pretty integral there, right? So not really something that's super easy to do when we're working with the fractions and the decimals and stuff like that. But what if instead of doing it this way, there was another way we could do this? What if we could do this just by factoring the bottom? So what if we just did that, say, x squared minus 5x, let's see, this is x minus and x minus. Factors of 6 that add to make 5 are 3 and 2. So what if we could break this up into something over x minus 3 and something over x minus 2? All right, so could that be something that'd be easier to integrate? Well, both of these, if we had to integrate this, say, with respect to x, and this with respect to x, and this with respect to x, these would all be really straightforward. This would be like whatever's on top, if it's just a constant, times the natural log of x minus 3. And this would also be whatever's on top times the natural log of the absolute value of x minus 2 plus c. All right, so now the question becomes, how do we find what's on top here, right? Because if we just put these fractions back together, like we got a common denominator, we just end up going back to that. So this is where the process comes in for partial fraction decomposition. It's how do we find those factors that go on top? So the first thing we do is we factor the denominator. So this will be x plus and x minus. Factors of 2 that subtract to make 1 are 2 and 1. So now it's factored. Write out each factor with a constant on top. So we'll say that it's, say, a over x plus 2 and b over x minus 1. And that would be equal to 9 over x squared plus x minus 2, like that. All right, so that's step 2. Solve for the constants. Clear the denominators and plug in strategic x values. So to clear the denominators, we're going to multiply both sides or all of this equation by x plus 2 times x minus 1. So when we multiply it by this guy, the x plus 2's cancel out, and we get a times x minus 1. When we multiply it by this guy, the x minus 1's cancel out, and we get b times x plus 2. When we multiply it by this guy, this cancels out with this because that's exactly what that is factored. So we just get equals 9. And this same process works every time. It's always just whatever the opposite factor is. So like a times the x minus 1 down here, b times the x plus 2 over there, equals what's on top over here. All right, now we pick strategic values of x to plug in. The most strategic I see right away is let's try x equals 1 because that makes this go away. So we get 0 plus, so 1 plus 2 is 3b equals 9. So that means b must equal 3. Another strategic value I can plug in would be -2. So if I plug in -2, this term all goes away, the b goes away. And really, we could plug in anything because we know b by now. But if we plug in -2 here, we get -2 minus 1. So that's -3a equals 9. So a equals -1. So now we can write out the integral with these factors. So we can say that the integral is now the integral of, let's see, we're going to have -1 over x plus 2 dx plus the a was -3, not -1, sorry, -3. Yep, and b is going to be 3 over x minus 1 dx. So this integral is equal to this. All right, again, the 3's don't make any difference on top. We just would do basic substitution with u being what the bottom is, and du would equal dx, and we'd get natural log. So we'd get negative 3 ln, absolute value of x plus 2, plus 3 ln, absolute value of x minus 1, plus c. All right, so now we can put the 3's in as exponents, and we can put the natural logs together and do some simplifying. So if we bring in up this negative 3 and bring up this 3, and then put our logs together by using the addition of log rules, what we get is the natural log of the absolute value of x minus 1 to the third over x plus 2 to the third plus c, like that. Or we can have this all to the third. That's fine too. All right. So there we go. So we do end up using natural logs an awful lot here. All right, here's a couple more. So now these are a little bit more difficult with an x on top, but again, we just do the exact same thing we were doing before. We factor the bottom. So this is going to be x plus and x minus. Factors of 6 that subtract to make 1 are 3 and 2. All right, so we'd get, say, a over x plus 3 plus b over x minus 2 equals 3x plus 4 over x squared plus x minus 6. All right, so if we multiply everybody by our common denominator, which is this guy right here, we're going to get a times this factor, b times this factor equals the top here. So a times x minus 2 plus b times x plus 3 equals 3x plus 4. Some of my handwriting is getting bad here. All right, we pick a value to plug in. A good one would be, I don't know, maybe 2. So this goes away. When we get b, 2 plus 3 is 5, so 5b. If we plug in 2 here, we're going to get 6 plus 4 is 10. Oh, b equals 2. Hey, that's nice. If we plug in, say, x equals negative 3, because that'll cancel out the b term over here, we'll get negative 5a. 3 times negative 3 is negative 9. Negative 9 plus 4 is negative 5. So divide both sides, and we get a equals 1. So we plug back in back here. So we get 1 over x plus 3. And then b is going to be, let's see, 2 over x minus 2. So that's what this whole thing here is equal to. So now we can just split it up and take the integral of each part. So we get the natural log of the absolute value of x plus 3 plus 2 times the natural log of the absolute value of x minus 2 plus c. You can leave it like that if you want. Or you can bring up the 2 and then put the insides together, and you could say that this is the natural log of the absolute value of x plus 3 times x minus 2 squared plus c, like that. That would work too. Again, at that point, you're just trying to match whatever the answer is on the AP exam. All right, so we got one more here. This guy factors into, well, that's just going to be x times x minus 1. All right, we're just factoring by pulling out a greatest common factor. So we could say that's a over x plus b over x minus 1 equals 4x plus 5 over x squared minus x. We multiply by our common denominator, which is this denominator here. So we get a times this factor plus b times just x equals the top here. All right, an easy number to plug in would be, say, 0. So we'll get negative 1a equals 5. So it looks like a is negative 5. Another easy number to plug in would be 1. So if we plug in 1, we get 1b equals 4 times 1 is 4 plus 5 is 9. So now we've got a and b. So now we can say we've got the integral of, let's see, so that's going to be negative 5 over x dx plus the integral of 9 over x minus 1 dx. So this is negative 5 ln of the absolute value of x plus 9 ln the absolute value of x minus 1 plus c. And we can bring these in as exponents and then put them together if we want. Again, we don't always have to do that. I just like practicing exponent rules and log rules. So it's going to be x minus 1 to the 9th over x to the 5th plus c. All right, so that is how partial fractions work. There are other types of partial fraction decomposition where you do with x squared and repeat terms, but we're actually not going to look at those. So this is just what we get to in this class. Back in the day, we used to do a little more, but that's it for now.